Today we shall study about total internal reflection in ray optics and optical instrument chapter of the optics. The figure of the total internal reflections at different angle is given in figure 1. When light travels from an optically denser to a rarer medium at the interface, it is partly reflected back into the same medium and partly refracted to the second medium. This reflection is called the internal reflection. When a ray of light enters from a denser medium to a rarer medium, it bends away from the normal. For example, the ray AO1B in figure 1, the incident ray AO1 is partially reflected O1C and partially transmitted O1B or refracted. The angle of refraction R being larger than the angle of incidence I. As the angle of incidence increases, so does the angle of refraction till the ray AO3. The angle of refraction is pi by 2. The reflected ray is bent so much away from the normal that it grazes the surface at the interface between two media. This is shown by the ray AO3D in the figure. If the angle of incidence is increased still further, it means the ray AO4, the refraction is not possible and the incident ray is totally reflected. This is called the total internal reflection. When light gets reflected by a surface, normally some fraction of it gets transmitted. The reflected ray is always less intense than the incident ray, howsoever smooth the reflecting surface may be. In total internal reflection, on the other hand, no transmission of light takes place. The angle of incidence corresponding to an angle of refraction, 90 degrees, say angle AO3N is called the critical angle IEC. For the given pair of media, we see from a Snell's law that if the relative refractive index is less than 1, then since the maximum value of sin R is unity, there is an upper limit to the value of sin I for which the law can be satisfied, that it is I barabar IC, so that sin IC barabar n to 1. For values of I larger than IC, a Snell's law of refraction cannot be satisfied. And hence no refraction is possible. The refractive index of in denser medium 1 with respect to rarer medium 2 will be n to 1 over sin IC. Critical angle of some critical angle of some transparent media with respect to air. For butter, crown glass, dense flint glass, and diamond is given in table 1. Now, total internal reflection in nature and technological applications. First is mirage, second is diamond, third is prism, and fourth is optical fiber. Now, mirage, मृग कृष्णा, इसे हम कृष्णा भी कहते हैं. On hot summer days, the air near the ground becomes hotter than the air at higher levels. The refractive index of air increases with density. Hotter air is less dense and has a smaller refractive index than the cooler air. If the air currents are small, that is, the air is still the optical density at different layers of air increases with the height. As a result, light from a fall object such as tree passes through a medium whose refractive index decreases towards the ground Thus, a ray of light from such an object successively bends away from the normal and undergoes total internal reflection. If the angle of incidence for the ear near the ground exceeds the critical angle, this is shown in figure. Now the diamond. Diamonds are known for their spectacular brilliance. Their brilliance is mainly due to the total internal reflection of light inside them. The critical angle for diamond ear interface is very small. Therefore, once light enters a diamond, it is very likely to undergo total internal reflection inside it. Diamonds found in nature rarely exhibit the brilliance for which they are known. It is the technical skill of a diamond cutter which makes diamonds to sparkle so brilliantly. By cutting the diamond suitably, multiple total internal reflection can be made to occur. Prism designed to bend light by 90 degree or 180 degree make use of total internal reflection. In figure 2A and B, such a prism is also used to invert images without changing the size in figure C. In the first two cases, critical angle IC for the material of the prism must be less than 45 degrees as shown in figure A, B and C. Now the optical fiber. Figure 1 is shown in optical fiber, low end core and high end core. Nowadays, optical fiber are extensively used. For transmitting audio and video signal through long distances. Optical fibers to make use of the phenomenon of total internal reflection. Optical fibers are fabricated with high quality composite glass or quartz fibers. Such fiber consists of a core and cladding. The refractive index of the material of the core is higher than that of cladding. A bundle of optical fiber can be put to several uses. Optical fibers are extensively used for transmitting and reflecting electrical signals which are converted to light by suitable transducers. Obviously, optical fibers can also be used for transmission of optical signals.